So let's start building up our multiplier in Logisim. Now we're going to use the design that we've seen a couple of videos ago. So this is the design here. We have our x input or y input and our x times our y. We have our sign, which is dealt with by the exclusive OR, and we have our addition of our exponent here, and we also have the multiplication of the mantissa at this section here. Now in this video we're not going to do the rounding section, so we'll leave this little section off and we'll get that in the video after this one. So let's start off first of all with our x and our y and our output, and also the splitter here, which splits the signal into the sign, the exponent and the mantissa. So we're going to need an input pin, so that's an input pin there, and it's going to have to be a 32-bit. Right, and we'll call this input y, and we'll copy that, and we'll call the other input our x input. And then we're going to have our output here, and again it's going to be 32 bits, and we'll call this x times y. So that's us got a start on it. We just have to get the rest of the circuit built. So the first thing we want to do is split the signal up. Now you can note here on this that we have 32 bits. The least significant bit is here and the most significant bit is up here. So it's going to run through in this direction for 8, 16, 24 and then 32. So we want this most significant bit here to be our sign, and then we want the next 8 bits, which gets to this point here, to be our exponent, and then the remaining 23 bits here are going to be our mantissa. So in order to split this, we just go in and we use a splitter. Now it's going to have a fan out of 3, that means it's going to have 3 outputs. There's going to be one output for the sign, another output for the exponent, and a third output for the mantissa. So it means that if we connect this up here, we're going to have one value here for our exponent. So it's going to be a bit width of 32. Now you won't be able to see it because it's off the bottom of the screen here, but I'm going to head all the way down to the 31st bit here, and I'm just going to call that bit number 0. So 0 is the top bit, so that will make the top bit here the sign bit, and then I'm going to work my way up and make the next 8 will be values of 1, and you'll see this just coming in at the bottom of the screen. Now I'll get rid of my image so you can see a little bit better. So that's me now got 1, 2, 3, 4, 5, 6, 7, 8, and then the remaining ones you can see just at the bottom here are going to be values of 2. So we only need to do this once in order to set this up, and we can copy this twice, and we can use the other one for the x and also use one for the output as well. So I do suggest that you go ahead and you try and build this up, because you always get a better understanding if you go ahead and do the build yourself, and it makes the whole exercise a little bit more interesting. So that's us created our splitter, and this is the first section now practically complete. So we'll copy this, Control C, Control V, and we'll put the output here for our x as well. And we can also copy, and we'll face it the other direction. So we'll face this here and we'll face it west. That's us got access to all of the values that we require, and we've also got a method of concatenating that, as joining them all together. So let's go ahead and we'll do the sign part first, because the sign part is going to be the easiest part. So we've seen that in order to create our sign part, we take the sign from the x and the sign from the y, and we exclusive OR them, and that goes straight to the output. So that's relatively straightforward. So we'll take our sign for our y and our sign for our x, and we'll put it through an exclusive OR gate. So you get your exclusive OR gate here, and we'll make it a 2 input. And then we can take our output, and our output will go directly to our 31st bit. And you can see right away that it's actually started working. You see that the bit has changed to a value of 0. So we'll just check this out. Now it's pretty straightforward. We're going to have a 0, which is a positive value, and a positive value. So if we multiply a positive and positive, we get a positive output, which is a value of 0. If any of these two become negative, so that's a negative input, then we're going to get a negative output. Or if the y becomes a negative input, the x becomes a negative input, we get a negative output. If both of them become negative, then negative times negative will give us a positive value, as a value of 0. So that's us worked out how to do the sign bit. So we're going to move on now, and we'll look at the exponent. So you can see here that at the exponent, we're going to have to take the biased value of our exponent for x, that's our big EX. We're going to have to take away the value of 127 in order to get the unbiased value, small ex. And again for the EY, we're going to have to take our biased exponent EY and take away the 127 first of all. So it's not actually shown here in this diagram, but there's got to be a little block there in order to get it from the biased state to the unbiased state. And then we're going to have to add both of them together, and then we're going to have to take a copy of each of these, one with the value of b and one with the value of b plus 1. And then we're going to have our multiplexer, which is going to choose which of these values gets passed to the output as our final exponent. So let's go ahead and we'll do that now. Now, in order to ultimately test our multiplier, we're going to have a couple of inputs that we can put in, and we're going to have to know what the answer is coming out. So what we can do is open up the multiplier tool, which is in the resources section. So head in, open up the spreadsheet, make sure you're on the tools tab, and head into floating point multiplier. So you click on that. Now we might as well stick with what we've known before. So the numbers we multiplied together before were 492.75, and we multiplied that with a value of minus 0.7. And we've got our answer up here. So what I've done is I've taken a note of the hexadecimal values here. So that's a hexadecimal for x, and a hexadecimal for y, and also a hexadecimal for the answer. So whenever we work through this, we're going to be using the hexadecimal values in order to check the answer, because it's much easier to see these 8 values here than it is to constantly check the 32 bits of our inputs and outputs. Also, if we were to close this here, now don't press clear, just press close, then we're going to have access to the values that we expect to get out for our exponent. Now it's a little bit small here, but I think you can just about read it. So this is going to have the value for our biased exponent for y, which is 126. We're going to subtract off our 127, which will give us minus 1. We'll have our biased exponent for our x value, which will be 135. Again, take away the 127, we'll get a value of 8. We're then going to add both those together to get a value of 7. and we're going to then add the 127 back on to get the biased value, which is 134. And we've got to take a copy of this. We're going to have a copy of 134, and we're also going to have a copy of the xe plus ye plus b plus 1, which will be a value of 135. And then we'll be choosing between the 134 and 135, depending on the value of the highest bit. Now the highest bit of the multiplication here is a value of 1, therefore we're going to be choosing the 135 value. So our final exponent output should be this value here. So with these numbers in mind, let's go ahead and we'll start building up the section that adds the exponent in Logisim. So I've gone ahead and I've put the values in for our y and our values for our x. So our x values are going to be, just as a reminder, is the 492.75, and we can stick this here. And we've also got our y value, which is minus 0.7. I will stick that value just down here. Now, as I said before, we actually want to check these values using the hexadecimal as opposed to the binary values. So let's go ahead and we'll stick in a couple of probes, which will allow us to see the actual inputs in hexadecimal. So if you head up to probe here, and you can put that in, and we'll face that east, and we connect that up. Now we want it in hexadecimal, so you can head here, put it in hexadecimal, and you can see here now we've got the hexadecimal input, which is our BF and our 6 threes. Okay, so this here is the correct hexadecimal value for our minus 0.7. Now we can do the same for our y value, and we'll copy that. And you can see that we've got our correct value for our y value there. And that's the 43F and 66 and 3 zeros. Okay, so that's our 492.75. Now we're going to do the same for the output because we want to be able to check the output in hexadecimal as well. So we'll head up here and we'll put in the same probe. Now we'll be using these probes throughout the rest of the design. They're really handy in order to check our work and make sure that we're actually doing it and we're getting the correct results. Of course, we're going to get all x's in this because we haven't built anything yet for the rest of this section. So let's go ahead now and we'll do our first part of our exponent. So the first thing we wanted to do was subtract off the value of 127. So we can head down into a subtractor here. So we'll put one subtractor, and I'll move it down maybe to at this point. I'll just leave it at this point here. So here's a subtractor here. Now at some point as well, there's not a lot of room in the screen here, so I will have to move sections round about a bit as we go along. But we've got our two subtractors here, and we're going to take the exponent output for our y value in here, and we're going to have our exponent out for our x value over here, and we have to subtract off a value of 127. So in order to do that, we can use a constant. So if you head up here, you go to the constant section, and we can connect that to the other input. Now the constant is going to be a value of our 127. So we're going to have to click on the constant here, and it has to be an 8-bit, and we have to put in the value, the hex value for 127. The hex value for 127 is 7F. So we're going to subtract off 7F from this one, and we're going to do the same with the x value, and we'll get an output here which is the subtracted value. So again, we always check as we work our way through, so we can just check the values that we're putting in and the values we're putting out. So again, we'll get a probe and we'll face it east, and we'll put one of them, say this one's going to go here, and we'll actually face it south, and we're going to change this value here into our decimal value. So that's our 126 we're putting in, and we'll take a copy of this one here. Again, I suggest that you start building this up because it'll be a lot more interesting than just continue listening to me talk my way through it. But we're going to have our 126 here, and if we put a probe in the output, you'll see if we'll have to change the probe value to a signed value because we're subtracting this off and it can go to a negative value. So in order to do that, we just choose the signed decimal, and you can see here we've got our value of -1, and we'll do the same here. We've got our value of 8. We then have to take these and we're going to have to add them together. So we can take this one here and this one here, and we've got to put it through an adder. So we can use the Logisim adder here. Now we click this one here, and we're going to put the input in here, and the other input is in here. Now, as I said, I don't have a lot of room on the screen here, so what I'm going to do is I'm going to move the output just outside the screen, okay? Because we know the output is there, we know what it looks like, and it'll give us some room in order to see the rest of the design. So we've got our output here, and again we're just going to go and check our output, and this should just follow the routine that we've seen within the Excel spreadsheet. So that's, we've added them together, we've got a value of 7. So let's have a look and we'll see, and we'll compare that to what we had on our Excel spreadsheet. And there's our Excel spreadsheet, and it's exactly as we expected from our Excel spreadsheet. So let's go ahead now and we'll go through the section here. So we've done this part here, we've done this part, we've added on the 127, we subtracted off the 127 for the EX and the EY. So we've got to this part here, we've then done the addition, so we're now at this part here. So what we want to do now is add on the value of our bias, which is our value B, which is a value 127, and we want to add on another copy of it, which is going to be the B plus 1. So we end up with this EX plus EY plus B, and then EX plus EY plus B plus 1. So another thing to note here is that we've designed this here from top down, so it goes from the input to the output and top down. But whenever we're doing it in Logisim, some of the cells, for example, that add adders and subtractors, you can't turn them around 90 degrees. So it's, if I was to build it top down, it would just look a bit silly. So we've built the same circuit as we've got here, but we're building it from the left to the right. So the input's on the left and the output's on the right. So let's go ahead and we'll get this little section here. So we're going to have to take this and we're going to have to put it through another couple of adders. I'll just adjust this here. So we'll put it through another couple of adders. Another one here, Control C, Control V. And we'll take a copy out to here. And we'll take a copy up into this one here. Now we're going to add in the value of 127. So again, we can use the constant, and our constant is going to be, in this case here, we're going to be adding on the value 127 and also the value 128. So that will be our B and our B plus 1. So our 127 is our 7F. We'll add that in here. Now our 128 is actually going to be a value of 80 in hex. We'll connect that there and we'll change this here to 80. So that's going to give us our 127 and our 128 added on to the value of 7. So let's have a look at the output here with our probes. So let me just change this here, and it's going to be an unsigned decimal. So that's the value of 134 as we expected. And we'll look at the other value here. And again, that should be 1 greater. And we've got our value of 135. So that's what we expect to get out. Now we have to do a choice between both of these. So we're going to have to go through a multiplexer to choose between one or another. So you can head into the section here called plexers, and there's a multiplexer there. So we take the multiplexer and we'll pop the multiplexer here, and we'll just connect one input to one input to the multiplexer, and this goes to the other input. Now the multiplexer is going to have to be an 8-bit, so it's an 8-bit multiplexer. Now there's going to be a choice as well that's going to be made for this multiplexer. So the choice is going to come out here, and we'll just take the choice along here, and it's going to have to come in. So the value for this choice is going to come from the 48-bit of the multiplication. But we've not done the multiplication section yet, so we can just leave this hanging for the moment. But we're going to have an output here then, and we can again put another probe at the output, and we won't have a value in it at the moment because the multiplexer isn't connected. But if you connect this here, and now let's say we have a high output from bit number 48, so you can do a test on this. You could just put a pin there and you can just force it. So what we can do here then, I'll change this output here to an unsigned decimal. So if the value here is a value of 0, then we're going to get the 134, which is the EX plus EY plus B. But if the output bit for the 48th bit is a value of 1, then we're going to get the EX plus EY plus B plus 1. So that makes the correct choice here. So that's us covered the little section on the exponent. We need to go ahead now and actually build up the multiplication so that we can get this value here that will make the choice for our exponent value. So I think that's enough for this video. We'll go ahead in the next video and we'll multiply the mantises. Thank you for listening. I'll get you on the next video. Goodbye.